To everyone, today we are going to see about the digital communication laboratory experiment. Our subject code is 20AC501 digital communication. Today we are going to see about the sampling and reconstruction experiment. This is our sampling and reconstruction trainer kit. This is CRO. First, before doing the experiment, we have to check the probe is working or not. So that we have to connect the positive terminal of the probe is connected to this 2 volt. We are getting a square wave, so we can identify the probe is working. After that, we are from the kit. This is our modulating signal. This is carrier signal. DC BCD counter. It is in comparator. It is in modulating input. From this we have to find out the sampled output and reconstruction output. We know that we have to provide. This is what our sampling signal. First we have to measure the input signal. We have to measure the input signal. This is what our input signal. Here we want to measure the reading. This is our modulating signal. It means that input signal. Here we have to measure the reading from the positive off cycle to the negative off cycle. Here one positive cycle and one negative off cycle. The amplitude is 1, 2, 3, 4, 4.4. Here 2 lines. One line contains a 0.2 value. So it is an 1, 2, 3, 4, 4.4 volt. Here if we have to multiply the multiplier component, it is in 1. So we can write 4.4 into 1 volt. And next we have to measure the time period. Here from positive cycle to the negative cycle. This is our positive cycle. Here one box we completed and the second box, it is a second line we crossed. So this is an 1.4 into 2 milliseconds. In this way we have to take the reading. Next we have to do the connection in the clock pulse. Here we are applying, we want to measure the carrier signal reading. For low frequency only we can measure the carrier pulses reading. This is what our carrier pulse. The amplitude is 1, 2, 3, 3.8 into 1 volt. Our time period is, similarly we have to measure the positive half cycle and negative half cycle. Here the positive half cycle up to the negative half cycle we have to measure the reading. Here the negative half cycle is end the third line. So 1.6 into 0.2 millisecond. This is what our time period calculation. Similarly, we have to measure the model sampled output. Before sampling the output, we have to do the connection. This output and the sampling input signal and this modulating input signal into the modulating input signal. This is what our sampled output. Sampled output we get it. This is what our sampling output signal. We have to measure the sampled values refer to the previous reading calculation. Next we have to see the sampled and hold output. This is what our sampled and hold output. This sampled values hold on here, so it is called as an sample and hold output. Next we have to measure the reading, flat top reading. Here it is nothing but our amplitude of the every sample is flattened here. So this type of output is called as an flat top output. From the sample and hold experiment, we can measure the 3 variety of output. One is in sampled output and second one is in sample and hold output, third one is in flat top output. Next we have to do the reconstruction. Reconstruction is nothing but we have to get the again we have to get the original signal from the sampled input signal. So we have to do the connection like this. It is in sampled output and we have to do the reconstruction input, and we are choosing a 500 Hz as an input signal, so I can choose this reconstruction condition. This is what our sampled output. After sampling, we have to measure the amplitude and time period. Here we are measuring the amplitude 1 to 2.4 into 1 volt. Here amplitude is reduced after reconstruction, but our concept is we are not getting time variations. Here in the previously modulating signal also we are measuring 1.4 into this 2 millisecond. Here also we are getting the time period is 1.4 into 2 milliseconds. From this output we can understand without time variation we have to receive our modulated output signal. This is what reconstructed signal. In this way we have to take the reading. Thank you.